All right, question number 10. Two balls, one of mass 2m and one of mass m collide. The diagrams show the initial and final velocities of the balls. Which collision is not elastic? The question suggests that all of these are elastic collisions besides one. So what do we know about elastic collisions? Perfectly elastic collisions have the property that the initial kinetic energy will equal the final kinetic energy. That, combined with the fact that the momentum is going to be conserved, is enough to sort of derive an idea that you can see in another video, that the relative speed of approach, which is kind of like how fast do the objects see each other initially, the relative speed of approach will equal the relative speed of separation. How fast do they sort of see each other after the collision? The relative speed of approach equals the relative speed of separation. Again, that's going to be true as a consequence of the fact that, you know, like we could say 1/2 2mv squared plus 1/2 mv squared and do a lengthy calculation with kinetic energies, but oftentimes it's simpler to just consider their relative speeds. When two objects are traveling in the same direction, you subtract their speeds to get the relative speed. When objects travel in the opposite direction, you add. Think about passing a car on the highway. It's going in the opposite direction than you, and it's zooming by you, right, at like twice the speed you're going. If you're both going 70, it seems like you're passing each other at 140. You're adding your speeds to get the relative speed. But if somebody passes you at 80 and you're doing 75, it only seems like they're passing you at 5, right? So you're subtracting each of your speeds to get the relative speed there. So anchoring your thoughts to a familiar example is the way to get out of trouble when you get confused. You're like, oh, what's the rule again? Do I add or subtract here? So it makes the calculation quite simple when we just say, okay, before the collision, these are going the same direction. 4 minus 1 is 3. These are going in the same direction. 5 minus 2 is 3. That checks out. That one is elastic, right? Only one of these is not, right? So most of them should be like this. 6 minus, so same direction. 6 minus 3 is 3. Same direction. 7 minus 4 is 3. Check. Elastic. 8 minus 2 is 6. 8 minus 5 is 3. That should be our correct answer, but let's just prove it to ourselves that 10 minus 4 is 6 and 12 minus 6 is 6. They're all going in the same direction, right? So it's all subtract. If they're going in the same direction, the relative speed of approach equals the relative speed of separation in choices A, B, and D. So the correct answer to this question, the one that is not elastic, must be choice C. And that's definitely the way you want to go about these calculations, rather than trying to entertain the idea that like, well, 1/2 2mv squared equal, you know, and treating it with the sort of kinetic energy.